Hello everyone, this is Javed, lecture Mathematics International Maritime College. These are outcomes for this video. First of all, we need to learn about concavity in the shapes. What does concave up mean and what does concave down means? This shape demonstrates concave up behavior and this one is concaved down. So part of this concave up curve will also be concave up. Similarly, part of the concave down will be concave down. So concavity in the curves, so they are concaved up and they are concave down. Concave up and point of inflection. In this curve before A, the curve has concave down behavior and after B, the curve is concaved up. So point of A is point of inflection. Concave down, concaved up. So it justifies that point A is point of inflection. In curve B, we have 2 points A, B, both are point of inflection because 2 times concavity gets changed. Before A, it's concave down and after B, concave down, and in between them, it is concaved up. So it has 2 points of inflection. At A, concave down to concaved up, and at B, from concaved up to concaved down. So concavities are changing, so 2 point of inflection. In curve C, before O, point of the O is point of inflection. Before O, it's concaved up, and after O, it's concaved down. So O is a point of inflection, and concavity change from up to down. Key points. If the double order derivative is positive, the curve will be concaved up. Second order derivative is positive means concaved up. If second order derivative is less than 0 or negative, it would be meant it is concaved down. And if the concavity changes from up to down or from down to up, we refer that point as point of inflection. In this example, we are going to find the point of inflection of the curve. So we take 2 derivatives. First order derivative will become 3x square, then second will become 6x. We can also write it like this. This is another way writing derivative representing this by bars. First order derivative by first 1 bar, second order derivative by 2 bars. Let the second order derivative equal 0 because at the point of inflection the second order derivative has been 0. So after taking it equal to 0, the x value will come out, and then we plug in this value into the function. So it means 0 and 0 is the point of inflection, which tells us that before this and after this curve there will be either both of concavities. So let's see the graph. Actually it is concaved down before the point of inflection, and it is concaved up after the point of inflection. There is an exercise for this. You should try this, and answers are given there, so you can take answer from the Moodle. Example 7.1.1, determine maximum minimum points and point of inflection, differentiating with the help of rule 3, first order derivative and second order derivative. First of all, we calculate point of inflection. So for point of inflection, we take the first order derivative equals 0, and we plug in that first to simplify it. So point of inflection x equals 0 or x equal to 2. So x equal to 0 and x equal to 2 are the maximum or minimum points. Now we'll apply the second order derivative, which one is maximum and which one is minimum. So at x is equal to 0, the second order derivative result comes -1, which is negative. And in the earlier slides, the key point was that if the derivative is coming, the second order derivative is coming negative, so it means it is concave down and it will be a maximum point. Now let's see at x equals 2. At x equal to, the second order derivative is coming 1, which is positive, and in the key points we studied that if the second order derivative is positive, it would be meant that it is concaved up, and concaved up means this is a minimum point. As a whole, I have repeated this question on one slide. Point of inflection, then we solve it for x, 2x values. At x equals 0, double order derivative is negative. Double order derivative is negative means this is concaved down. So concave down refers to maximum point. At x equals 2, the double order derivative is positive, which means it is concaved up. Sorry. So this is a minimum point. Another example, derivative, first order derivative, then second order derivative, and first of all we go for the point of inflection. We take it take it equal to 0. We solve it for x, 2x values are coming. Now we need to determine if x equals -1 is maximum point or minimum, the same way that we will also determine 2. So at x equals -1, the double order derivative is coming positive, greater than 0. When it is positive, the concavity is up, which refers to the minimum point. And at x equals 2, the double order derivative is coming negative. Negative means it's concaves down, and concave down refers to maximum point. There is an exercise. Questions, answers are given in the book which I have uploaded on Moodle. You can do them easily. In case of any problem, you discuss with me. Thank you.